Students, welcome to my YouTube channel. In this video lecture, I am going to answer questions from sample paper number 4, RK Bali navigation book. This is the 4th edition book. In my previous video lectures, I have answered first 30 questions. In this video lecture, I am going to answer the next 10 questions, beginning from question 31 up to question number 40. So let's start with question number 31. With respect to aeroplane loading in the planning phase, which statements is always going to remain correct? So before that, I will just give you a rough idea of the format of your weight and balance. You always start with basic empty mass, okay? And when you add variable loads, now variable loads means the mass of crew baggage, food, water. Okay, so when you add variable loads to your basic empty mass, you're gonna get DOM, that is dry operating mass. Now next thing, when you add takeoff fuel or fuel on board, that is the fuel in the fuel tanks when aircraft is lined up with the runway on the threshold ready for takeoff. The fuel remaining in the fuel tanks at that point of time, okay, that is called takeoff fuel or fuel on board. So DOM plus that fuel will give you operating mass. It will give you operating mass. Next, DOM plus payload, okay, will give you zero fuel mass. So DOM plus payload, zero fuel mass. Zero fuel mass means no usable fuel, no takeoff fuel in the fuel tanks of your aircraft. Nevertheless, zero fuel mass will include unusable fuel. Okay, so DOM plus payload is going to be your zero fuel mass. Next, zero fuel mass plus takeoff fuel or fuel on board will give you takeoff mass. Okay, zero fuel mass plus fuel will give you takeoff mass. Operating mass plus payload can also give you takeoff mass. So there are two ways to get takeoff mass. Follow this route or follow the second route. Okay, so operating mass plus payload is going to be your takeoff mass. Zero fuel mass plus takeoff fuel is also going to be your takeoff mass. And the third way to get takeoff mass is with the help of DOM, that is dry operating mass plus useful load is going to give you takeoff mass. Now, useful load is takeoff fuel plus payload. Takeoff fuel plus payload. Takeoff fuel plus payload is going to be your useful load. So DOM plus useful load, nothing but takeoff fuel and payload, gives you takeoff mass. Now let's check the options. Landing mass. Now how will you get landing mass? Takeoff mass minus trip fuel gives you landing mass. Takeoff mass minus trip fuel gives you landing mass. Okay, so landing mass is takeoff mass minus trip fuel, option A, right. Bravo. Maximum takeoff mass equals to zero fuel mass plus maximum possible fuel mass. Okay, so maximum takeoff mass is equal to zero fuel mass plus takeoff fuel or fuel on board, that is going to be in your fuel tanks, okay, when aircraft is lined up with the runway. That means this takeoff fuel will exclude from consideration your taxi fuel and engine startup fuel. So you are going to subtract that fuel and you are going to only consider that fuel which is going to remain in the fuel tanks at the time of takeoff. So therefore option Bravo will be wrong, because you are not going to include all the fuel in this calculation. You are going to only include takeoff fuel. That means you are going to exclude taxi fuel, engine startup fuel. Okay, so Bravo is wrong. C, maximum zero fuel mass equals to traffic load plus DOM. Okay, so maximum zero fuel mass equals to traffic load plus DOM. So this is zero fuel mass. This is not maximum zero fuel mass. This is only zero fuel mass, not the maximum limit. Maximum limit is fixed. Zero fuel mass can differ with changing payload and changing DOM. So option C will also remain, will also be wrong. So the correct answer will be always, the correct statement which is always going to remain true, okay, in all situations is going to be option A. Okay, so always correct. Next, question number 32. For the purpose of completing mass and balance documents, traffic load is considered to be equal to what? Is it takeoff mass minus operating mass? So takeoff mass minus operating mass is payload. So that statement is right. Operating mass plus payload gives you takeoff mass. So when you subtract operating mass from takeoff mass, you are remain with payload. So option A is okay. Bravo. Traffic load is considered to be equal to plus operating mass plus trip fuel mass. So let me just check this question 32. Yeah. So the traffic load is considered to be equal to takeoff mass less operating mass. Yes. Takeoff mass plus operating mass. So takeoff mass plus operating mass. So that is wrong. We do not have any possible equation in which we are going to add operating mass to takeoff mass. We can only subtract that. Next. So Bravo will be wrong. Traffic load is considered to be equal to takeoff plus trip fuel. So we do not have anything called takeoff plus trip fuel. We have takeoff minus trip fuel. So option C will also be wrong. So option A is the correct option. Question 33. The center of gravity of an aeroplane may only be moved if permitted by regulating authority and endorsed in the plane's certificate of airworthiness, is fixed and is unaffected by loading, can be allowed to move between defined limits. So correct answer is option C. The center of gravity will move as your flight progresses. Okay. So you have two types, two limits. Okay. So you have two center of gravity limits. You have the forward limit, you have the backward or aft limit. So forward limit and aft limit. The center of gravity can move between these two limits if it wants. Okay, the center of gravity can move between these two limits. It can move forward, it can move backward, but it cannot exceed this limit. It cannot move forward of this forward limit, or it cannot go backward of this backward limit. It has to remain within the limits in order to have stability. So correct option is it can be allowed to move between defined limits, is in a fixed position. That is wrong. Is unaffected by loading? No. It is affected by loading. As you load your aircraft, as the fuel in your fuel tanks gets consumed during the journey of the flight journey, the CG will be affected or influenced by that, and it is going to move. So Alpha and Bravo are wrong. Question 34. In a direct reading compass magnet, it is made aperiodic by what thing? Aperiodic means no oscillations, no oscillations. So a magnetic compass is made aperiodic by damping action of compass liquid. Okay, they use some kind of alcohol. So it's methyl alcohol. You can check the chapter. You can read the chapter magnetism from RK Bali. Very important. Okay, so there you will find that fact. The correct answer is option C, damping action of compass liquid. There are other courses of action also by which you can make a compass aperiodic. Question 35. Which of the following statements is correct? The maximum takeoff mass is equal to maximum mass when leaving the RAM. Next. So that means maximum takeoff mass is equal to maximum RAM mass. Basic empty mass is equal to mass of the airplane excluding traffic load and usable fuel, but including crew. Maximum landing mass is restricted by structural limitations, performance limitations, and the strength of the runway. So now maximum takeoff mass is equal to maximum mass when leaving the ramp. So that is not going to be equal because your maximum takeoff mass excludes taxi fuel, excludes engine and startup fuel. But the weight of aircraft when it just leaves the ramp will have taxi fuel in the fuel tanks. Correct? It will have, or it will also have fuel for startup and engine startup. Correct? So takeoff mass will not be equal to ramp mass. Option Bravo states basic empty mass is equal to mass of aeroplane excluding traffic load and usable fuel but including crew. So that is also wrong. Okay, crew is included in dry operating mass, not basic empty mass. So if you check this, uh, this uh, this thing. So variable load is where you have crew mass or crew load. Now basic empty mass plus crew or variable load gives you DOM or dry operating mass. Okay, so crew or variable load will be included in dry operating mass, not basic empty mass. In the basic empty mass, you only have the standard mass of your aircraft, unusable fuel, oil, all that things. So question number 35. So Bravo will also be wrong. You are left with option Charlie. The maximum landing mass of your aircraft is always restricted by structural limitations. Your aircraft will have maximum landing mass, structural landing mass. Again, landing mass will also be restricted by performance limitations like density, altitude, the climb restrictions, climb gradient, strength, or the strength of the runway, right? So all these factors are included in performance. So option C is the right answer. The datum is a reference from which all moment arms, balance arms are measured. Its precise position is given in the control and loading manual and it is located where. Now always whatever uh, measurements that you want to calculate center of gravity. So in order to calculate center of gravity, you need to have balance arm or moment arm. Moment arm means let's say there is a weight added here. So you will have to measure the distance of this weight from the datum of your aircraft. Now this datum can be anywhere. This datum can be anywhere. It can be in your aircraft, like means in the beginning of your aircraft, that is the nose section. It can be in the tail section. This datum can also be outside your aircraft. So this datum can be here. Okay, an imaginary datum can be here. So if it's outside aircraft, let's say over here, you will measure the distance of this particular object, of this particular weight from this datum. Okay, like this. If this datum is going to remain here towards the back of your aircraft, so you're going to measure the distance arm backwards like this. Okay, so datum can be anywhere in your aircraft. So correct answer here will be it is this datum, a reference imaginary datum, is located at or near the natural balance point of the empty aeroplane, at or near the forward limit of the CG, at a convenient point which may not physically be on airplane. So that is right. So it can be anywhere at any convenient point and not necessarily only on aircraft. It can be outside it also. 37. Mass and balance calculations. Which of the following describes the datum? It is the most aft position of the CG. No. It is the point on the plane designated by the manufacturers from which all CG measurements and calculations are made. Yes. It is the distance from the CG to the point through which the weight of the component acts. That is wrong. It is not the distance measured from the CG. Datum is the point on the airplane designated by manufacturers from where all CG measurements are done. Okay. 38. Vertical soft iron magnetism. Now there are two types of magnetism. Read that. Hard iron magnetism, because of the structure of your aircraft, the metallic components that are used. And we have vertical soft iron magnetism. or just the soft iron magnetism? Soft iron magnetism is because of the magnetic field of the earth. And what is vertical soft iron? Like you all know, the magnetic field of the earth has two components, horizontal and vertical. Now I have done this or described this many times in my previous video lectures. Let's say this is your earth. Your magnetic compass requires horizontal component of the earth magnetic field. Let's say this is the equator. This is the pole, north pole, okay, south pole. So we have two components. We have horizontal component, we have vertical component. Now the horizontal component of the magnetic field is maximum at the equator, and this horizontal component is minimum or zero at the poles, any pole, either pole. Similarly, vertical component is minimum at equator, and this vertical component is maximum at poles. So your magnetic compass will be most effective, or it will work properly at lower latitudes, especially the equatorial latitude. As your latitude increases, okay, as your latitude increases, horizontal component of the magnetic field decreases in value and vertical component increases. And your magnetic compass is dependent on horizontal component of the magnetic field. So if that decreases, your magnetic compass also becomes ineffective, meaning more and more unreliable. Okay, so this is called vertical soft iron magnetism. That means uh, uh, errors produced in the magnet due to the vertical component of the earth magnetic field. So vertical soft iron magnetism, strength increases with increase in magnetic latitude. Strength varies as cosine of magnetic latitude, has the same polarity in both hemispheres. So option A. As your latitude increases, vertical soft iron magnetism will also increase. 39. In high-speed aircraft, the true airspeed is determined by means of what? Airspeed indicator. So it will indicate indicated airspeed, calibrated airspeed. Mach meter, yes. So when your aircraft flies at tremendous speeds, very high, fast to air speeds, you are going to use Mach meter. Now Mach number or Mach meter indicates Mach number, which is nothing but a representation of true airspeed of your aircraft in terms of or with respect to local speed of sound. Let's say you're flying at ISA mean sea level. At ISA mean sea level, local speed of sound is 661 knots something. And if your aircraft true airspeed, the real airspeed of your aircraft is also 661, then the Mach number will be 1, 1.0. That means true airspeed is equal to your local speed of sound. You are flying as fast as a sound will travel in the atmospheric medium. Now let's say your true airspeed of aircraft is half of 660, somewhere around 330. Okay, that means it is half of local speed of sound, half of 661 knots at ISA mean sea level. So your Mach number in that case will be zero point 0.5. Half of 1 is 0.5. That means you're flying half the true airspeed at a true airspeed of half the local speed of sound. Okay, so in high-speed aircraft, TAS is determined through Mach numbers with the help of Mach numbers. So Mach meter will not directly indicate true airspeed, but it will indirectly show you true airspeed with respect to your local speed of sound. So option Charlie. The local speed of sound will keep on changing as temperature of the atmosphere keeps changing. Local speed of sound is 39.17 square root of temperature in Kelvin. So it is proportional to temperature. Temperature increases, local speed of sound increases. Temperature decreases, local speed of sound will also decrease. Question 40. It is possible in flight to do what many things. Okay. So there are four options given to you. Let's say you're flying an aircraft. Okay, you're flying aircraft. So is it possible? It is possible to file an IFR flight plan in flight. Yes. Let's say you're flying aircraft. Okay, it's a normal flight, and you have not filed a flight plan before departure. Now you have taken off, you're airborne, you're in cruise, and let's say you suddenly encounter IMC conditions, instrument meteorological conditions, and you think it will be super wise or prudent to get ATC clearance, to get ATC services to be flying under ATC supervision, so as to be safe, right? To get correct weather updates since you're going to enter IMC conditions. So in that case, you choose to select or you say choose to file an IFR flight plan. Okay, when you are airborne, so that is possible. You can do that. Question number two, you also get a priority when you are when you are filed an IFR flight plan. You are an IFR flight. You will also get priority over other VFR flights. Next, modify an active IFR or VFR flight plan. Yes, you can do that. You have already filed a IFR flight plan or a VFR flight plan. You're conducting your flight, you are in cruise portion, let's say, and you want to make some certain changes in your flight plan, like your cruise altitude, the true airspeed, cruise speed, whatever that is, you want to make changes and you want to notify that. So you can modify your flight plan. You want to cancel an active VFR flight plan. So you're flying, you're on a VFR flight plan, you're getting radar services, you're getting flight vectors and all that. And suddenly you choose to fly on your own. Okay, you consider you need not require any more ATC services or ATC supervision. You want to fly on your own, dead reckoning, let's say, and you want to practice that kind of cross country flight or that kind of navigation, you can choose to end your flight plan in air. So that is also possible. Close an active VFR flight plan. So that is also possible. You can close an active VFR flight plan in air. Okay. So correct option will be all the statements here are correct. Option 1, 2, 3, 4. So the combination of correct statements. So you will select that combination, that option which has all these four combinations. Okay. So this concludes our lecture. I hope you have understood all the 10 questions I answered in this video lecture. I hope you are getting the knowledge and you are getting becoming more and more confident in answering the questions from sample papers. I have solved many questions from other sample papers as well, and I have uploaded them to my channel in one dedicated playlist. You can go to playlist section of this channel and check that playlist, RK Bali sample papers. I have put all the sample paper lectures in that playlist. I wish you all the best. Thanks for your time. And one more request, I will like if you share this channel, this particular video lecture with your friends who are also preparing for the exam. Thank you.